Hello dear friends, in this video today I am going to discuss the functional equation, and functional equation is a very important topic for IIT-JEE Mains and Advanced. So today topic is functional equation. Let's start with it. First of all, what is functional equation? Functional equation. So first of all, what is functional equation? It is an equation involving unknown function, unknown functions is called functional equation. So actually this topic is a big topic. I will make 2-3 videos of this to cover the whole chapter. So this is the first video on this functional equation. So what is functional equation? An equation involving unknown functions is called functional equation. For example, suppose if I take an example for functional equation, it is if I am writing f of x is equal to f of minus x. So this is a functional equation, and this will holds for every even function. Every even function. So this is one of the functional equation. There are several functions. I am just taking a simple example. So suppose this function is satisfied by fx is equal to x square, fx is equal to mod x. So the solution of functional equation is one or more than one, but the solution of functional equation can be unique if there are some additional condition are given, like continuity, differentiability at a point, and the value of function at some particular points are known, then the exact functional equation can be determined. So this is the definition of functional equation. Now after that, some standard result for the functional equation, or you can say the standard functional equation, or sometimes we say this as quasi-functional equation. What are those? First is if fxy is equal to fx plus fy, then we can take in this case the function fx is equal to k ln x. Obviously we are talking about here the non-zero and non-constant function. So point is fx should not equal to 0 and fx is non-constant. Because fx equal to 0 can also satisfy the functional equation, but we are finding here non-zero and non-constant function. So if any functional equation satisfy this condition, then in that case fx can be taken as k ln x in this case. This is the first standard functional equation. Second is f of xy is equal to fx into fy. In that case, you can choose fx is equal to x to the power m. This is second standard function equation. Third is if f of x plus y is equal to fx into fy. In that case, we can take fx as a to the power x. And the fourth, the standard one, is f of x plus y is equal to fx plus fy. In that case, you can choose fx is equal to kx. In this case, fx is linear. Yes. And the fifth standard result that we need to remember is if fx is any continuous function, if fx is any continuous function and only takes a rational value, then it must be a constant function. Must be a constant function. So on this result, there are one simple question asked in IIT-JEE, that if a function is a continuous function and only takes rational value, then function can be taken as a constant function. So that example, you can take that example as just let me take that example. It is given that fx is a continuous function and only takes a rational value, and f of 2 is equal to 5, then find f of 10. So obviously if a continuous function takes only rational value, so it must be a constant function, because as we know that between every two rational values or irrational values there are infinite rational and irrational values. So in this case it is possible only when it is a constant function. So obviously f10 must be 5. Now let's move to the next point. In this point we can discuss if fx is a polynomial of degree n and satisfy the condition is fx plus f of 1 by x is equal to fx into f of 1 by x. In that case fx can be taken as fx is equal to 1 plus minus x to the power n. So whenever it is given that fx is a polynomial function and satisfying this condition, so this condition, in that case fx can be taken as fx is equal to 1 plus minus x to the power n. We can consider one example on this sixth property also. Suppose we have one example like this, that if f is a polynomial function, if f is a polynomial function satisfying the condition is 2 plus fx into fy is equal to fx plus fy plus f of xy for all xy belongs to R, and f of 2 is equal to 5, then find f of f2. Now how to solve this question? Since earlier in the point 6 we discussed that fx is any polynomial function satisfying this condition, so fx can be taken as this, but here condition is a little bit different, but there is a use of that property. How to use that property in this example? Let's solve this question. Since result is given that 2 plus fx into fy is equal to fx plus fy plus f of xy, and this is true for all xy belongs to R. So Now replace y with 1 by x in this equation. Replace y with 1 by x. What we get? It is 2 plus fx into f of 1 by x is equal to fx plus f of 1 by x plus f of 1. Now if we prove that f of 1 equal to 2, then we will get the required functional equation, and from there we can take fx is equal to 1 plus minus x to the power n. But for that we need to prove f of 1 equal to 2. Then how to prove f of 1 equal to 2? Now consider this functional equation again. This is a functional equation. Let's use this functional equation to prove f of 1 equal to 2. How? In this functional equation, put x equal to y equal to 1. So what we will get? 2 plus f of 1 into f of 1. So f of 1 whole square equal to 3 of f of 1. So from here we can see that f of 1 can be 1 or 2. F of 1 can be 1 or 2. But as we know that function cannot take two values. It is not possible that f of 1 is 1 also and f of 1 is 2 also. As we know from the vertical line test, that function always take a unique image. So f1 cannot be 1 or 2. So f1 can be 1 or 1, can be 1 and 2. But we need f1 equal to 2. So how to prove that f1 is not equal to 1? So as in the question it is given that f of 2 equal to 5. Now we have two values of f of 1. Now again use the same functional equation. In this functional equation, let's substitute x is equal to 1 and keep y as it is. So what you will get? 2 plus f of 1 into f of y is equal to f of 1 plus f of y plus f of y. What we done in the functional equation? This is the functional equation in 1. We put x equal to 1 and keep y as it is. So when you put x equal to 1 and suppose let f of 1 is equal to 1, मान लेते हैं कि f of 1 1 है. So how to prove that f of 1 is not equal to 1? Let's suppose that f of 1 is 1. Now if we use this result, what we will get? F of 2 plus f of y is equal to f of 1 plus 2 times f of y. Again f of 1 we can put f of 1 as 1. So from here we will get f of y is equal to 1. So from here, if we take f of 1 is equal to 1, from here we can see that it gives fx as a constant function which is 1. But fx cannot be a constant function, as in the problem it is given that f of 2 is 5. If it is a constant function and then f of 2 must be 1. So f of 1, f of y is equal to 1, that means it is a constant function. So this assumption that f of 1 is 1 is not true, because it is giving the result that fx is a constant function, which is not possible since f of 2 is 5 and here f of y is 1. So finally we will get f of 1 is equal to 2 only. This is the result. Now if you use this result f of 1 is equal to 2 in this functional equation, we will get this result 6. If you put f of 1 equal to 2, it both will get cancelled and we get this functional equation. So as we know that any polynomial will satisfy the condition fx plus f of 1 by x is equal to fx into f of 1 by x, then we can take fx is equal to 1 plus minus x to the power n. Now we have to find n. With the given result, this f of 2 is 5. So when you put x equal to 2, you will get f of 2 is equal to 5, or we can say 1 plus minus x to the power n is equal to 5. So from here we need to take the plus sign only so that function is defined. So from here we can, after comparing, we can say that x to the power n is 4. So we take 2 now, so put x equal to 2. So here, from here we can say 2 to the power n is 4, so n must be 2. So our function must be 1 plus x square. So once you get the function, that is the solution of the functional equation. Since additional condition are given, so solution is unique. Now you have to find f of 2. So as we know, f of 2, we have f2 is already 5, so we need to find f of 5, and which is 26. This is our final answer. So today we started functional equation, and we use some standard result, this first, second, third, fourth and fifth. If it is any continuous function and takes only rational value, that must be a constant. And sixth, polynomial one. Fx is a polynomial which satisfy this condition, then fx can be taken as this. On that sixth result, we took this problem and we solve it, and final answer is 26. So these are some standard functional equation which we discussed, but there are some other questions based on the functional equation. We will solve the different types of functional equation. After completing some functional equation which do not require differentiability, but there are lots of problems which based on the differentiability of a function. Using differentiability also we can find functional equation, or we can solve the functional equation, but that part we will do in the next video. But here we are discussing few more question based on the functional equation. Let's discuss few more question. Now the second question is, I am taking some simple example now. After that we will increase the level of the question. For x belongs to R, the function fx satisfy 2fx plus f of 1 minus x is equal to x square. Then find value of f of 4. How to solve this question? So this is a simple example of the functional equation. We have functional equation as 2fx plus f of 1 minus x equal to x square. This is a functional equation. Functional equation is an equation which involve unknown function. We don't know the function. We need to find the function first. So how to find this function? In this type of question, just replace x with 1 minus x in the equation. So you will get 2 times f of 1 minus x plus f of x is equal to 1 minus x whole square. Now from equation 1 and 2, eliminate f of 1 minus x, then you will get fx. So you have to eliminate f of 1 minus x from this equation. So when you eliminate f of 1 minus x from these two equations, what you will get? Put the value of f of 1 minus x here from 1. So you will get 2 times f of 1 minus, put f of 1 minus x as x square minus 2fx plus fx is equal to 1 minus x whole square. So finally you will get fx is equal to x square minus 1 minus x ka whole square. Or you can simplify it further. Now they are asking the value of 4. So finally what is f of 4? It is 2 of f of 1 minus x. Sorry, I think we forget to multiply with the 2. You need to multiply with the 2 here also. Look, it is a 2f of 1 minus x. So multiply with 2. Yes. So if you multiply with the 2, it is what? 2x square minus 4fx plus fx is equal to 1 minus x whole square. So from here, fx is equal to 2x square minus 1 minus x whole square upon 3. Now we have to find the value of f of 4. It is what? 2 into 16 minus 9 upon 3. So finally, after simplification, we will get the answer 23 by 3. So this is the answer of this question. So this is a simple question. and the answer of this question is 23/3. Let's discuss one more question on the functional equation. This type of question generally asked in JEE Mains every year. So it is a standard question, and this is let fx is equal to 9 to the power x plus 9 to the power x plus 3. Find a value of fx f of 1 upon 1996 plus f of 2 upon 1996 up to f of 995 upon 1996. Okay, how to solve this question? So generally in this type of question, you can see that generally if you find fx plus f of 1 minus x, you will get some constant. It's not like necessary that f of 1 and 1 minus x is constant, but generally it is f of x plus f of 1 minus x or f of x plus f of 2 minus x become constant. We need to use this result. From here we can see if this is x and this is 1 minus x, so obviously fx plus f of 1 minus x in this case is constant. So if you find f of x plus f of 1 minus x in this question, what you will get? 9 to the power x plus 9 to the power x plus 3 plus 9 to the power 1 minus x upon 9 to the power 1 minus x plus 3. So after simplification of these quotient, you will get the value. After if you simplify this expression, you will get the value as a 1. So fx plus f of 1 minus x in this quotient is 1 after simplification, and then you have to find the value of this expression. Now from here you can see that if you take the first from the beginning and last from the beginning, these are of the form fx plus f of 1 minus x type. So if you combine these two, you will get fx plus f of 1 minus x. Similarly, we can combine first, last, again and again. So finally, this type of combination, this will give value 1, and there are how many combination of this? We have f of this, and again f of 2 plus f of 1994 upon 1996. So in this way, we will get 1994 upon 2 combinations, and the value of each is 1. So the value is 1994 plus upon 2 plus one value you will also get, which is f of 998 upon 1996, which have no combination. So this is nothing but f of half. So finally you have to find the value of this, which is 999, and if you find f of half, which is equal to half. So finally answer is, it is I think it is 997, not 999. It is 997 plus half. So finally is 997.5 is the final answer. So this type of question is generally asked in the JEE Mains. We will discuss more problem based on this, but in this video, that's all in the functional equation. But this is a big topic. We will discuss few more question based on this. There are several question, and this kind of question also, which in PYQ also in the next class. But in today class, that's all for today. Thank you so much for watching.